So, imagine you're asked to prove this by induction, okay, which you are. But, imagine for argument's sake that I didn't give you this. There's a circle. Imagine I didn't give you that part, alright? And I just blanked that out completely. And I said, no bother, you don't exist. And I just asked you that. Prove that by induction, alright? So here's what this means. See n equals 1. That means set your equations to start off at n equals 1. See the n squared part. That's your Tn. See the top part? That's where you stop. So that's your stopping point, and that's your starting point. So what's our very first? What's T1 essentially? 1 cubed. Okay. T2. Yeah. T3. All right. And we get the gist, right? 4 cubed, and then plus dot dot dot, and Tn. Right. So this. That's great. This middle part here essentially means everything on the left. Is that alright? So essentially the middle part has no real function as such. There's that circle again. Now, so is everybody happy that the middle part means the left part? Alright? So all we're going to do is compare the left hand side to the right hand side, and that's how we're going to sort this. We're going to sort out underline this in right and underline this in green. Right? Green is Sn. Red is, that's TK, that's T4. We get the gist, don't we? Alright, so you're going to go through the exact same process you did last time. You're going to prove for n equals 1, you're going to assume true for n equals k, and then you're going to prove for n equals k plus 1. Off you go. I'll give you about 6 minutes and then I'll come in after you. Alright guys, that is a very valid question. Lads, alright, prove true for n equals 1. We'll start with the left hand side, which means we'll start with T1, which means we'll start off with 1 cubed, which is 1. Then we'll do the right hand side, which is S1, which is 1 squared over 4 into 1 plus 1 squared, which is a quarter of 4, which is 1. And then you say LHS equals RHS, true for P1, or true for n equals 1. Everybody get that far? We hope. 5 marks, well done, 5 out of 20. Now to pass it, can you replace all the n values with k to get 10 out of 20? I know, it's tough going, yeah. Now, you're on part 2. Assume true for P of k. Sorry. Assume true for n equals k. Rewrite the full thing, which is frustrating to say the least. But marks. You can write the center part if you want. I don't generally do it. We alright with that? Right. Now please remember that part there is TK. And now we're going to add on a TK plus 1 in a second, right? Part 3. Prove true for n equals k plus 1. Alright lads, 1 cubed plus 2 cubed plus 3 cubed. Gonna run out of space, so I'm just gonna go straight into TK cubed. Oh, sorry, TK. Now what's TK plus 1? What do we replace k with? Replace k with k plus 1. Okay? And then on the other side, it's no longer sk, it's s of k plus 1. And what is s of k plus 1? It's going to be k plus 1 squared all over 4, and replace that k with what? K plus 1, which will turn that into k plus 2 squared. And I'll pause there. Has anybody got any questions for me on that? Next thing, What did we say about the part I'm underlining in black? What is that? That's the series from T1 all the way up to TK. And what did we say about that earlier? It's the same as SK. So this part here that I'm boxing off in red should be equal to this part here I'm also boxing off in red. So I'm just doing a direct substitution. Is that okay? So what do I write down here instead? K squared, K plus 1 squared all over 4 plus K plus 1 cubed equals this to the right. Now it's looking very complicated, but I'm sure we can find a way to make it a bit easier. Okay. Any ideas with regards to common denominator? Common denominator 4 would be a good call, okay? So if I grab this here, controlling, alright, just cloning it. Now, so what am I going to put in here? I'm going to put a 4 down here, and a 4 up here. Is that okay with you guys? What can I factorise out on the left hand side? Just something that I can factorise out of both of them. Yeah, I can take out the K plus 1 squared. And what else can I take out? I can take out the 4 on the bottom, can't I? And what's left over then? Would everybody agree K squared is left over? And what about here? Plus 4 into. Now I think that's the step you'll all struggle with. Am I correct? Right. Do you agree that if I multiply that back out, if I multiply K plus 1 squared over 4 by K squared, what do I get? Alright. Would everybody agree that K squared multiplied by K plus 1 will get you this here? Is that alright with you guys? And then what happens when we multiply this part by the second part? K plus 1 squared by another K plus 1 get you K plus 1 cubed. The 4 on the bottom, the 4 on the top and the 4 on the bottom will come back in. So it's exactly the same, okay? Now, and it equals the right hand side. So does anybody know what the next move is? What are you going to do in here? You're going to multiply that out, aren't you? And when you multiply that out, you get 4k plus 4. And what happens when you factorise this quadratic? What will you get? Exactly. And are they both the same?
Yeah.
So you're just after conclusively proving that both sides are the same. And what do you have to write again? We'll see if we remember how to say it. P of k plus 1 is true if what is true?
P of k is true.
Okay. And then what else are you going to say?
From principle of mathematical induction.
Hence, by the principle of mathematical induction.
P n is true.
I always forget to spell principle. It's L-E, isn't it?
Yeah.
Not A-L. You always get that mixed up. That's the principle of mathematical induction. P of n is true.
Yeah.
Okay. So, good news is you're going to do the odds. Better news is it's on video as one of your assignments, so you shouldn't have any issue getting through it. Is that alright? So for tonight you're going to do 1, 3, 5 and 7. And in today's class I did 2, 4 and 6, wasn't it?
Yeah.
Alright.